In this video, we'll compare histograms to other visual analysis tools like dot plots, box whisker diagrams, and the Pareto chart. The learning objectives will be to build each of these in QI macros and then show some of the strengths and weaknesses that each of the visual charts has. Okay, I'm in one of the course data files right now. We're taking a look at a call center case. It's called the New Tech Wireless case. The data file is called Call Center Student Data. And in the case, there's 2 years of historical data on average hold times. And the first thing I'm going to do is just create a histogram of that historical data. To create the histogram, I'm going to highlight my data. Here's a quick pro tip. If you press Control, Shift, and the down arrow, that'll highlight it all the way to the end of the region. We've got about 730 of those data points. I go to QI macros. I choose histograms capability, and I'm going to choose the histogram with CPK normal. And this is a review. You should be familiar with creating histograms by now, but subgroup size is 1. The upper specification limit from the case is 110 seconds is the maximum that people want to be waiting on hold. So we'll specify that. There's no specification, no lower specification limit, so we'll click cancel here, and we'll just let the default number of bars show up on the chart. All right, and so there is a histogram for these 700 data points. We get a sense of central tendency. I'm gonna zoom in. We get a sense of central tendency here with our mean value. We also get a sense of spread by taking a look at the width of our histogram output. We even get with this blue bar a comparison of how our data looks compared to a true normal distribution with mean of 99.66 and standard deviation equal to 24.25. So great, we've got our histogram. Life is good. Now, sometimes though, you might want to create a different visual display. Histograms can be a little bit overwhelming, especially with all of this data and spec limits and descriptive statistics. Is there a simpler way to display this data? And that's where dot plots can really be handy. Instead of me describing what a dot plot is, let me just build one I think you'll see right away. But it's a dot of each data point laid out in histogram style. It's almost like a frequency histogram. Let's take a look at how one looks. So I'm going to go back to my day ordered data, my 730 data points. I'm going to go up to the QI macros menu, and instead of going to histograms, I'm going to go to box dot and scatter plots, and I'm going to choose the dot plot. Just a real simple display of the data in that data set. No descriptive statistics, no upper and lower specs, but for some audiences, it might be easier to understand and easier to make decisions from with a simple dot plot. Here's the problem though with dot plots. They start to break down when you have smaller data sets. So in this example, we had 730 data points. Let's take a look at some data where the sample size is much smaller. So in our in that call center case, we also had some future state data. There were 30 data points. I'm going to highlight that data, and I'm going to do the same thing, creating a dot plot. And that's what the dot plot looks like with 30 data points. It's not very spectacular, not very insightful. There's where dot plots break down. When you have smaller data sets, they're just not as useful. Let's now take a look at building another visual display tool that can help you with variation. It's called a box whisker diagram. I am first going to build a box whisker diagram from a single column of observational data. That's not my preferred way of using box whisker diagrams. I find that box whisker diagrams are most useful when you're comparing multiple category groups, let's say by we're observing 3 or 4 operators, 3 or 4 machines, 3 or 4 different product SKUs. But I'm going to start with just one just so that you can see how to build it, and then we'll take a look at multiples. So I'm back to the call center data case. We had just created a dot plot of the future state data and found that dot plots weren't that effective at really understanding what was going on. Now I'm going to build a box whisker diagram. I'm going to highlight my data, and then I'm going to go up to the QI macros menu and again go to the box dot scatter plot section. And instead of choosing dot plot, I'm going to choose box and whisker diagram. It asks, do you want to group by row or column? And this is column data, so I'll choose column. And there's the result. What box whisker diagrams do is they show they show quartiles, or how much of your data falls within particular quartiles. So the first quartile is represented by this whisker. And it goes, and the way that I'd interpret this is that the first 25% of the data of that data set goes from approximately just under 51 to just about, looks like about 64, 65. The second quartile of data is represented by this green box. And that goes from just about 65 to around 80.75. The third quartile of data is in this gray box right here. The third quartile of data goes from about 80.75 to 85. And then the fourth quartile, or the last 25% of data, goes from just about 85 to 100, and I'm eyeballing about 115. The nice thing about box whisker diagrams is that people understand or can more quickly intuitively understand groupings by 25%, 50%, 75%, 100%. These quartile ranges can make sense to folks. And this boxed region where we've got the second and the third quartile, the two together, that big combined box, we call that the interquartile range. It's where half of your data lies. If the data that we're looking at were a normally distributed output, it's where the mound is in your mounded hump. Speaking of normal or non-normal data, another nice thing about box whisker diagrams is that these quartile ranges that are calculated and determined, they will work regardless of normal or non-normal data. One of the issues with histograms and working with non-normal data is that we can't use that empirical rule of 68, 95, 99.7 when we have non-normal data. And box whisker diagrams doesn't matter if you've got normal or non-normal data. One of the other things that you can do with box whisker diagrams is that it's pretty easy when building a box whisker diagram to show outliers. Outliers are defined in a box whisker diagram mathematically. It's anything that is more than 1.5 times this interquartile range. So we figure out where 50% of our data lies. We figure out the range, and then we multiply by 1.5. And anything that falls outside of that will mark as an X to indicate that it is from box whisker diagrams, a mathematical outlier. We'll take a look at another data set now so that you can see what outliers look like in a box whisker diagram. Okay, in this next example, I've got 3 operators, Wendy, Phil, and Mike, and they are working on a machine. In this particular data set, the machine that they're working on is they're shooting a little toy catapult. In the course, it's one of the tools that we use to collect data are these fun little toy catapults. But you could substitute catapults with saws, with drill presses, with the time it takes to complete a mortgage loan application in minutes, the time it takes to withdraw or to complete a transaction at the bank window to withdraw cash from a person's account in seconds. And it could be anything. I've got three different operators, and I've got their output values. Let's do a box whisker diagram now of Mike to get a sense of what his central tendency and variation is. So I'm going to highlight Mike's data, go to the QI macros menu, choose box whisker diagram. It's being grouped by columns. And, there's Mike's data. You get a sense of where the first quartile is, second quartile, third quartile, and then the last quartile. The big boxed region of the two rectangles is called that interquartile range. Does not appear to be any outliers because there are no data points that are further than 1.5 times the interquartile range. And where do we get 1.5? It's just the definition that is used for box whisker diagrams. But now let's go back to that original data. Okay, so we're back to the original data. We've seen Mike's output, looks like kind of a standard box whisker diagram. Let's say, though, that his next attempt, he messes up. He flubs up, and it shoots, I don't know, 15 instead of the usual values. How would that look in a box whisker diagram? So we'll highlight this data. I'm going to go to QI macros, box whisker diagram, group by columns. And now you can see how outliers are identified in a box whisker diagram. They are defined as being 1.5 times the interquartile range. Anything that's either above or below 1.5 times the interquartile range will identify itself as an outlier with these little X's. Okay, so box whisker diagram's a simplified view of spread and central tendency. Okay, let's go back to the original data set. I'm going to clean it up and get rid of that data point that I just put in to show outliers. The real power I see in box whisker diagrams is that they allow you to quickly view central tendency and spread across multiple groupings. So we've got three operators here, Wendy, Phil, and Mike. Instead of creating three single box whisker diagrams or creating three single histograms and stacking them next to each other to understand their performance against each other, the real power of box whisker diagrams comes in highlighting all the data and creating one big diagram. Let me show you what I mean. I'm going to highlight each person. I'm including the names here so that we can see those names in the final box whisker chart that's created. But I'm going to highlight all my data with the headers. Go to QI macros, choose box whisker, group by columns. And what I love about this particular diagram is I can now see performance across Wendy, Phil, and Mike all side by side. And I can start to get some pretty good understanding of what's going on here. Wendy's right here. Wendy, very little spread. All three of the operators have the pretty similar central tendencies. That's where the middle of this interquartile range is. So it's not like there's a centering issue, but clearly Mike has a lot of variation in his output. Phil has a lot of variation, and especially a lot of variation on the low end, below the median here. And so we can start to analyze the system to try to understand, well, what is it that Mike is either doing, or how is the process set up for Mike that is creating all this spread? What is Phil doing, or how is the process set up for Phil that's creating all these low values over here? Or we can go over to Wendy's setup and take away some of her best practices. I love box whisker diagrams because they allow me to look at multiple category groupings together and make some decisions about central tendency and spread. Okay, to stick to our promise of keeping to 15 minutes or less, I'll treat Pareto charts, the next topic, as a separate part 2 video. See you in part 2.